All right. It's a very short thing. I want to teach you how to find the trick to finding the um, sine, cosine of special angles. Is that clear? So what you do is you draw your finger, okay? You don't have to draw yet, so just watch me first. Is that clear? So this is your finger. You divide your finger into two like this. Each finger you divide into two. Is that clear? So you now put sine. Now before you put sine cos, you now do like this. You put your special angles. What are your special angles? 0 granite, 30 granite, 45 granite, 60 granite, 90 granite. Is it clear? Now, you want to know how to find their sine and cosine. Is that clear? So this is what you now do. You put sine here, cosine here. Sine, cosine, sine, cosine, sine, cosine, sine, cosine. Is it clear? Now, this is what you want to do. The answer to any question I ask you is going to be the root of that answer over 2. Should I repeat myself? And for every this thing I ask you about the number of fingers and all, it will be root that number of fingers over 2 each time. So let's start with 0, for example. If I say, give me sine 0. Sine 0 granite is going to be like this. You ask yourself, which side is sine? Is sine on this side or that side? This side, right? How many fingers are after this side? Eh? No finger again, right? So it will be root no finger over 2. What is root 0? 0 over 2. 0 over anything is what? 0. So sine 0 is 0. Let's try for cos 0 now. Cos 0 granite. Cos is on which side? This side. How many fingers are remaining on that side? Let's count. After EM. 1, 2, 3, 4. It's 4. So it will be what? Root 4 over 2. Square root of 4 over 2. 1. So cos 0 is what? Has it stopped? Okay, so I said that is for 0. Let's try for 30. So if I say sine 30 granite will be equal to 30 is here, right? Now sine is on which side? This side. How many fingers are left on that side? 1. Yes, sir. So that will be root 1 over 2. Square root of 1 over. So sine 30 is what? 1 over 2 or 0.5. Have you gotten the concept? Okay, now if you have gotten it, fastest finger, give me cos 60. Cos 60. Cos 60. Correct. Just do like this. Cos 0, 30, 45, 60. Cos on this side. Root 1 over 2. 1 over 2. Is it clear? Fastest finger, give me sine 45. Sine 45. How many where's the sign on this side? How many fingers? 2. Root 2 over 2. That's all. You know, you cancelled. Cannot cancel. This is square root of 2. Is it clear? Fastest finger, cos 45. Root 2 over 2 is still the same. So sine 45 and cos 45 are the same. Oh, sine 90. And so what's 2 over 2? Sine is on which side? This side. 1, 2, 3, 4. Root 4 over 2. Someone said this as the answer. You can't stop here. Root 4 is what? 2 over 2. This takes care of this. 1. Are you drunk? Cos 30. Root 3 over 2. You said 3 over 2. See your nose. Cos 90. 0. Once you is here, 0. That's all. Sine 0, 0. But cos 0, 1. Is it clear? Cos sine 60. Is it clear? So that's how to find special angles. So you don't need a calculator anymore, right? So if you subscribe to my lesson, I'll teach you more tricks. But I won't be around. I won't be around though, so don't worry. Because there's no time to be doing tricks in class, you know. Alright, now look at this one. I was going to teach you something in trig. A circle that has that the radius, a circle whose radius is 1 unit. Have you been taught first quadrant, second quadrant, third quadrant? Do you know that thing? Okay. Since you know it. No, I know you know what first quadrant is. I'm saying, do you know the application, what it is? Do you know how it was? Okay. They will tell you A, S, C, C, or cast. That all is positive, sine is positive, tan is positive, cos is positive. Do you know how that was derived? That's what I'm asking you. Do you? Do you? Yes or no? No, ahead. That's what I want to teach you. It's very simple. It's very simple. Follow me. Eh? Say. Look here. No, don't write. Just listen. It's what you can. It's a trick. It's not what you really. In fact, if you write anything, it should be this. And you may write it later. See, these are called quadrants. Quad means 4. So a circle has been divided into 4. Those 4 sides will be called quadrants. We always go anti-clockwise. We always go how? Anti-clockwise. So this will be called the first quadrant. Exactly. This second quadrant. Do you notice that we are making a 180 degrees here? Semicircle. So here, right angle, another right angle. Second quadrant, third quadrant, fourth quadrant. Does that make sense? I'll rub that off. I want to show you how it goes. So listen, any angle therefore, okay, no, let's do this again. So from here to here is what? 90 granite. From here to here, 180 granite. From here to here, 270 granite. Then from here back to this place, 360 granite. Good. Now, what's it? Okay, granite. What's it called? Degrees now. Yeah, it looks like granite now. That's why I call it granite. It's granite. Are your granites bigger than this? Yes. Oh. Let's go, please. Whatever you like to call it, whether it's degree or granite, just make sure you're listening. Listen. I said, so it means that, listen. Any angle that is less than 90, will lie where? In the first quadrant. Any angle that is greater than 90 but less than 180 will lie where? Second quadrant. Any angle that is greater than 180 but less than 270 will lie where? Third quadrant. Any angle that is greater than 270 but less than 360 will be what? Fourth quadrant. Is it clear? So don't forget that. Is it my phone or? Okay. That said, how do we now read it? How do we read it? Here's what we do. Remember that I told you that the radius of this circle is 1 unit. The radius is what?
1 unit.
So a unit radius circle, that is a circle whose radius is 1 unit. What does that mean? It means that from here to here, 1 centimeter. If it's centimeter or any unit, it could be meter, it could be centimeter, okay? So whatever the unit is, the value of that radius is what? 1 unit. So you know a radius is any line that goes from this center to the circumference, right? Alright, that's it. So let me now show you how they got that thing. See, if I go like this, I create an angle here, an angle theta. I open up an angle theta from here to here. I will join this place to make the pi out. Join it to the circumference because that's where the angle got to. Do you understand? So it will look like this thing just opened up. Is it clear? So, but to now deal with it, we have to make a right angle out of it, right? A right angle triangle. So to make a right angle, I'll just drop this guy down. Is it clear? So now to deal with this guy. Remember, what's the length of this place to this place? 1 unit. Is that clear? It could be any unit, okay? So it could be centimeter, it could be meter and all. Alright, now look here. There's something you have to now see. This place in your Cartesian coordinates, do you remember that this is x, this is, do you remember this one? This one is y, this is, okay. So we are going to apply it here too, that this is y minus y, x minus x. Alright. So anytime we are dealing with something up here to be positive y, we are dealing with something down here to be negative y. Something to the right, positive, something to the left. Alright, look at this. I call this my angle theta. So what will sine of that theta, that angle, what will it be? It will be equal to, remember sine, SOHCAHTOA, right? SOHCAHTOA. What is SO? Opposite over hypotenuse. So what is the opposite here? Okay, we have not labeled it. Let's label it. This rise is called y. This run here is called x. Rise, run. Is that clear? So now, opposite over hypotenuse, 1. Makes sense? So y here is equal to sine theta. Is it clear? Alright, I'm going to just give it to you in a way that is quite rudimentary. Alright, what about cos theta? Adjacent hypotenuse. What's our adjacent here? X over, so x equal to what? Cos theta. Does that make sense? Are you sure it makes sense? Okay. What about tan theta? Y over x. You don't need to write this one in terms of anything. Just leave it this way. But do you notice something? That the value of sine x, sine theta here is positive y. The value of cos theta here is what? Positive x. The value of tan theta is what? Positive y over x. So in first quadrant, all is positive. Is it clear? Let's go to second quadrant. Maybe as I'm going, this is opening up, It gets here, it doesn't stop. It continues to this place. So I'm going to draw the line to show that it opened up to this place. Now, if I want to use my SOHCAHTOA, I cannot use SOHCAHTOA directly in this big triangle. It's easier to use with right angle, isn't it? So I make a right angle out of this place. Let's label. These are guys still 1 unit, right? What this place be? Y, positive y. What this place be? Is it clear? Is it clear? They are confused, raise your hand. Okay, it's negative x. But our new angle, remember that the angle we are looking for is this big one here, right? So, but we want to look for a way to find this angle, this big theta, without necessarily using the big theta, but using the angle here. Let's call this one theta 2, this one theta 1. Is it clear now? Because if you look at it too, this angle, opening this angle from here to here is like opening a particular angle from here to here. Don't you understand? If I open this angle, if I open from here, stop here. It's just as if I open something from here to this place. Is it making sense? So that's why this angle too can work. But do we normally open in this direction? No, we normally open in this direction. So that's why the parameters that we'll use to describe this one will now change. It will change how? You can already see. See, what will sine of theta be? Sine theta, what will it be here? Opposite over hypotenuse, which is 1. So y equal to what? Sine theta. Do you notice that sine is also positive again? All right. Yes, dear. How are you? What about cosine? Let's go. Cos theta will be equal to what? That's cos theta 2 now. Adjacent, not adjacent. What's adjacent here? Minus x over 1. So x here is equal to minus cos theta. So what do you notice? Cosine is what? Negative. Let's try tan. What will tan give us? Tan theta. What is that? Y over negative x. Did you see we have a negative value? Alright. So in this side we say only sine is positive. You see it's only sine that is positive. So if you are taking now, listen, let me now tell you the implication of that. Which angles are going to be here? Angles that are greater than 90, isn't it? Let's do 120 now. If we take sine 120, if I say find sine 120, according to this equation, it should be the same as taking the sine of a smaller angle. Now, what is that smaller angle here? If we subtract this thing from 180, we'll get 60, right? So it should be the same as taking sine of 60. Why is it going to be positive? Because only sine is positive. Use your calculator now. Do you have a calculator? Do sine 120, you see it's the same as sine 60. Sine 120, sine 60. Are they the same? Good. But let's try this one now. If I now do cosine of 120, it cannot be the same as cosine of 60. It will only be the same as negative cosine of 60. Because cosine is negative. Try it. Cos 120 and do negative cos 60. Do negative cos 60 as well. The same thing. Do you notice now? If you have done cos 60 alone, you will not get the same answer as cos 120. So if I take tan of another big angle too, in as much as my angle is an angle that is big here, that is as big as staying in this place. Clear? All right. Should we go to third quadrant? Okay, no. We cannot write a rule here, Howie. We cannot write a rule. The rule is now that the sine of any angle, the sine of theta is always equal to sine of 180 minus theta, according to what we did here. Given that theta must be equal to 90 plus an acute angle, another acute angle. Do you know what I mean by this? That is, theta must be greater than 90 for this rule to work. Do you understand? That is, this theta must not be anyhow theta. If it's 40, sine 40 might not be equal to sine 180 minus. Do you understand now? Good. So for example, if I say sine 150 will be the same as what? Sine 150 will be the same as what? Sine of any angle in second quadrant should be equal to the sine of 180 minus that angle. So do it. Sine 30. So if I just come to you with, give me sine 150, you don't need to solve sine 150. Just do sine 30. Is it now clear? So if I say, give me cos 150, you don't need to do cos 150. What do? negative cos 30. Is it clear now? So you know that cos 30 is root 3 over 2. So you just tell me minus root 3 over 2, that's cos 150. Is it now clear now? That's what I want you to see with this thing. Is it clear? I'll stop at, okay, let's continue. We'll stop here because I'm going to the church, okay? See you tomorrow. We might continue tomorrow, okay?